Hello, geometry. Welcome to the last lesson of Unit 2. This lesson, you will learn some angle pairs, and these things are going to go with you all the way through geometry and probably beyond. So you definitely need to know these. Like I've said before, we're building a toolbox here that we're going to start using here in a couple units. All right. So angle pairs. There are 4 types of angle pairs we're going to look at in this lesson. Most of them have special relationships, characteristics that you can use. All right, the first pair are called adjacent angles. Adjacent angles are 2 angles with a common vertex and a common side. And remember, what in an angle, side is also a ray. All right, so I have an example here. Okay. I'm going to label these M, it's bad M, N, P, and I'll put this as R. All right, so angle A and angle B are adjacent angles. Okay, I'm going to abbreviate that. They're adjacent. The common vertex, well, what vertex do they both have? That would be N, right? They have a common side or a common ray. That is ray and R, right? You see how that is on both angles, okay? I said that there's special relationships, but I also said that most of them have special relationships. This is the one that does not. They're just right next to each other. That's it. There's nothing really special about them. They're just right next to each other. Okay. Vertical angles are something you're going to use a lot. Probably of all of them, this one or supplementary are the 2 angles that you're going to use the most of. Vertical angles are 2 angles whose sides form 2 pairs of opposite rays. Now, we've talked about opposite rays back in Unit 1. Opposite rays are 2 rays who form a line, but they also have the same endpoint. So, in other words, these vertical angles are opposite one another when 2 lines intersect. So, what are my vertical angles here? Well, those 2 are vertical angles. You see how those 2 angles are formed by basically 2 lines going on forever. Okay. We have another pair of vertical angles here. You may have noticed this one and this one. Those are vertical angles as well. What you're going to see and what you're going to find out, we're going to do it on the back, is vertical angles. I'm getting ahead of myself. We're going to talk about that on the back. There is a special relationship, but we're going to talk about it on the back. But one thing, vertical angles are never adjacent to each other. Since they're across from each other or opposite each other, they can never be next to each other. All right, so you're never going to see vertical angles that are adjacent. All right, moving on. Complementary angles are 2 angles whose measures add to 90 degrees. And supplementary angles are 2 angles whose measure adds to 180 degrees. Okay, both complementary angles and supplementary angles are sometimes adjacent. Not always, but they are sometimes adjacent. It's possible for them to be next to each other. Okay, a couple examples of just classifying these types of angles. Name the most specific angle pair being illustrated, and that's talk about that in a little bit. All right, so number 1, I've got 2 angles. I've got the angles are 27 degrees and 63 degrees. If I check that, 27 plus 63 equals 90. So that's 2 angles whose measure is 90 degrees. Those are complementary. And that is the only way we can classify those. Okay, it's complementary. Next one has a couple different problems with it. 1 and 3, so we're looking at this one and this one. Well, those are right next to each other, so they are adjacent, but the most specific is that they are supplementary. You see how together those form a line? If they form a line, that means they add to 180, which means they are supplementary. Okay, we call those two angles together something called a linear pair. Line, linear means line, and a pair means two. So two angles that make a line, which are also called supplementary. So they all kind of mean the same thing. Okay. All right, let me go ahead and clear that. It's getting a little messy. Okay. 3 and 4. Probably guess what these are. Those are across from each other, opposite each other. Those are vertical. Last one, number 3. A lot of people are going to look at that and say complementary because it looks like a right angle. There's nothing on here that says it's a right angle. Okay. So I cannot say that that's complementary. What I can say is that those two angles are right next to each other. So the most I can say about this one is that those two angles are adjacent. If I had a right angle here, then I would say complementary. Another example, a little more tricky. Name a pair of adjacent angles. There's lots of them, right? So any two angles that are next to each other. So I'll just say M and L. Notice I'm putting the angle symbol in there. M and L and L and K are adjacent angles, but there's lots. Okay. Name a pair of vertical angles. Now this one can get a little tricky. I'm going to do this one incorrectly first. So make sure you hear me when I say I'm going to do it incorrectly. I'll see people say angle INM and angle JNK. Well, let's do that real quick. They are kind of opposite each other, but there's a problem with that. Remember, in the definition was two opposite rays. Well, they all have the endpoint of N, so they all could be opposite rays, but NK does not form a line with any other ray. So those are not opposite. An easy way to see vertical angles, I'm going to clear all this. Easy way to see vertical angles is draw two lines and the angles that are formed. So if you want to use INM, that's fine. But what's across from it? It would be JNL. Now it's an overlapping. So you got two angles in JNL, but that's okay. The easier one would be angle INJ and angle MNL. Those are vertical as well. Okay. Name a pair of supplementary angles. Well, those are two angles that add up to 180. So I'll just say INJ and angle INM. INJ and INM. Those two angles form a line, therefore they're supplementary. Okay. Complementary angles. Well, I'm looking for that right angle. I see it there. What two angles form that? Now, here's what I see some people say. They'll say angle INK. Now, it's a problem because that's only one angle. You can't have a single complementary angle. Remember, complementary angle is two angles. So I need to take both pieces. Those are the complementary angles. So INJ and JNK. All right. Relationships now. I referenced this earlier when I was talking about vertical angles. We're going to get to it. Here we are. We will now look at some theorems concerning these angle pairs. Theorems are statements that can be proven. All right, so the vertical angles theorem says that vertical angles are congruent. Not too difficult to remember. The theorem is vertical angles are congruent. Another way of saying that, I'm going to turn that statement here into a conditional if two angles are vertical. So if I have vertical angles, then I can conclude they are congruent. So I'm going to prove that now. You're not going to have to do all this, but I want you to see it. It's going to help you start seeing how proofs work. So I'm going to take the hypothesis. Two angles are vertical. So angle 1 and angle 2 are vertical. That's the hypothesis. And I want to try and prove that the angle 1 is congruent to angle 2, right? So here's how I prove it. Angle 1 and angle 2 are vertical. I'll put angles there. And that's my first statement. I always want to start with my hypothesis. So I have that. That's given. Okay. I gave you that information. That's how I know that they're vertical angles, because I told you they were. Well, what else can I say? Well, I could say angle 1 plus angle 3 equals 180. How? That's the angle addition postulate, which we learned back in unit 1. But I could also say that angle 2 plus angle 3 adds up to 180 because of the same thing. So I'm going to leave those both as statement 2. Statement 3 then, well, if they're both equal to 180, aren't they equal to each other? So angle 1 plus angle 3 equals angle 2 plus angle 3. The reason I could do that is substitution. I substituted, since 180 equals angle 1 plus angle 3, I replaced 180 with angle 1 plus angle 3. You could also argue this is the transitive property, but we'll go with substitution. Okay, then what I'm going to do is I'm going to subtract angle 3 from both sides. And notice how it cancels on both sides, so I'm left with angle 1 is congruent to angle 2. That was the subtraction property. And look where I'm at. I've proven that the two angles are congruent. I've followed a step-by-step logic to get to the point where they're congruent. We'll work on those proofs in unit 4 a lot more, but I want you to start seeing how the proofs are laid out. Okay, but the big thing here, they are congruent. So angle 1 and angle 2 are congruent. Next, there's like 4 more. I'm not going to do all that proving with all of these, just the first one there. Congruent supplements theorem. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. Okay. You don't know this, but what I just did up there is pretty much the exact same thing as on that previous proof is what this is saying. Now I'm going to show you what this looks like. If I have two angles, call them angle 1 and angle 2 that look alike. Okay, maybe they don't, maybe they do. Call that angle 3. You know, I'm going to make that a little bit bigger so it fits. Okay. If I'm telling you or giving you that angle 1 plus angle 3 is 180 and angle 2 plus angle 3 equals 180, right? Then I can prove, or I can state that angle 1 is congruent to angle 2. Like I said in the proof before, we basically did that, right? So that's another theorem that you could use. We don't use it a ton, but you could use it, all right? The congruent complements theorem, if two angles are complements of the same angle, or if congruent angles and the two angles are congruent. So it's the same thing. If they add up, if they both add to 90, then they're congruent. Okay, number 4 is going to seem like a duh statement. All right angles are congruent. Well, yeah, because they're all 90, and 90 is always equal to 90. Okay, if two angles are congruent and supplementary, then each of those angles is a right angle. Now, I'm going to show you that one. Okay, so I have two angles. We'll call them X and Y. And I gave you two parts. So that, remember, the hypothesis is here. Two angles are congruent and supplementary. So the given here is X is congruent to Y, and x plus y equals 180. That's what supplementary means. We want to try and prove, or we can prove, that each of those is a right angle. So x and y, I'm going to write that a different way. Looks like x plus. X and y are 90 degrees. Well, that should make sense, because if I do a substitution, x and y are equal, I could say x plus, instead of y, I'm going to put x equals 90, or sorry, equals 180. Sorry. Writing feature here is not doing too great. There we go. But x plus x is 2x. Divide by 2 and you get x equals 90. And since x equals 90 and y is equal to x, y is also 90. So I just proved that last theorem. All right, so we're going to use these to find missing angles, and then we will be testing. So that's it.